Hello everyone, welcome to my video. In this video, I will explain a substitution technique called as a Playfair Cipher. So, what is the difference between Playfair Cipher and the previous one, that is mono-alphabetic cipher? That also let us discuss. Now, we have seen the Caesar cipher. We know what is mono-alphabetic cipher is. But even with a very large number of keys, what we can have in the mono-alphabetic cipher, that is 26 factorial maybe, it is not possible to provide a very high security. Okay, so there will be some similarities or structures of the plain text in the ciphertext by using which we can actually decrypt the message. Any attacker can attack very easily. Now, what is the approach? What is the method to improve the security? Then you go for Playfair Cipher. Okay, so what is the difference here compared to mono-alphabetic? Mono-alphabetic, one single alphabet is actually replaced by another alphabet, right? Substituted by another alphabet. But we can increase the security of the transmission or data transmission by encrypting more than one alphabet at a time or more than one letter at a time. Okay, best example is Playfair Cipher. So in the Playfair Cipher, we actually encrypt at a time two letters. Okay, so two letters are given as input and it will give you two letters in the output, a ciphertext. Fine. It is basically invented by Charles Wheatstone, as mentioned here, right? And but it is named after his friend Baron Playfair. Okay. Now, what is the structure is? How exactly the encryption is done in this particular method? That let us understand. Now, for any encryption algorithm, key is required, right? In the Caesar cipher, we have seen that we need actually a key, which is a number basically, maybe 3, 4, 5, 6. We shift by that particular number. The alphabet is shifted by that key, by the value of the key. But in this case, we actually use a word, okay, an English word maybe, as the key, as mentioned over here. Just look at this. So we have this monarchy as the key over here. Okay, the monarchy is a key. And usually we actually arrange the alphabets, okay, by using that particular keyword in the 5x5 matrix. Okay, we have to fill those cells of the 5x5 matrix as it is shown on the right side. That is, just look at this. So we start with to say the keyword, the alphabet of the keyword. The alphabet of the keyword is like, say, monarchy, monarchy, right? We start by filling this monarchy. Okay, we end up here. Then we actually fill the other cells of this particular 5x5 matrix with the remaining alphabet, which are actually not covered here. Okay, which are not exactly covered. So just look at this, monarchy is filled. Suppose in the keyword, if any of the alphabet is repeated, that is omitted when you are filling it up here. Okay, only once the alphabet is actually entered. Okay, that is, let me say, India is the keyword, INDIA. So in my word India, I actually repeats two times, right? But it is filled with only one time here. Let me say INDA. That's all. Okay. The second time, the I which appears is actually omitted, and we have to fill the other cells with the remaining alphabet, whatever are not covered. Now coming back to this example here, monarchy is written over here, and we have not covered B, D, E, F alphabetically. The remaining alphabets are actually entered in this particular grid, that is 5x5 matrix. So hence, say B, D, E, F, G. Now you can just look at this particular cell, I/J. That means we have actually 25 cells, but we have totally 26 alphabets, right? So this I and J are written together so that you can fill it all these 26 alphabets by using a 5x5 matrix. Okay, so I and J are actually written together over here. This is the first step. Okay, use a particular key, fill this grid or matrix with those particular alphabets. The key can be anything. It can be India, it can be, say, good morning, or whatever it is. Okay, next, what is the next step? So I have the same matrix here, 5x matrix here for a keyword matrix, keyword monarchy. So how to encrypt the data? Okay, what is the procedure or step-by-step procedure to encrypt the data which I will tell you? Okay, let's look at this. If say a pair is repeated letter, insert a filler like X. I have to. Okay, say in my plain text, I have a word balloon, okay, where BA, the L is repeated, O is repeated, and followed by N, right? If the pair is repeated, that is double L I have, double O I have, okay, it should be converted first in the plain text itself before you encrypt as BA, LX, LO, and ON. So between this, double L, the X is actually increased. I mean, X is actually included, and we are converting the word into a group of two letters. We call them as diagrams or digraphs. Diagrams or digraphs. So we have a digraph here, group of two letters BA followed by LL actually in the plain text, but it is written as LX. Then followed by say LO, which are two different alphabets now in the diagram, right? And ON. This is your plain text now initially. So wherever you have such repeated letters, insert a filler X. Now, while encrypting, now I am ready with my word, say balloon, now whatever that word is. Just an example I have taken. I'll take a complete example later and how to encrypt I'll tell you. Now, suppose if both the letters fall in the same row, okay, in my plain text, suppose two letters fall in the same row, let's say BA, the first one is BA, right? They actually fall in the same column, okay? Suppose they fall in the same row, for example, say AR, okay? I have a A here and R here. Both the alphabets in my plain text, let me say, they are falling in the same row, okay? How to replace or how to encrypt it? Okay, you have to replace each letter to the right of that. Let me say I have a here. Okay, in the encrypted version, replace A by R and R by wrapping back to the first alphabet, that is M. So A R is replaced by R M. Okay, let me say one more example. Say I have a, let me say PQ. Okay, or P and S. Fine, P and S. Whatever the letter appears next on the right side, that is Q and T, that's it. So PS has to be replaced by Q and T. Okay, now this is one row. If it is falls in the same column, then same method, you just have to go down, that's it. Okay, say for example, okay, now here, second. MU is taken an example here. See, M and U both are falling in the same column, right? So M has to be replaced by what? C. Okay, and U wrapping back to the top, that is M. Okay, so suppose in your plain text you have MU. Fine, it has to be replaced by what? C and M. Okay, or for example, say I have in my plain text I have Y and G. The equivalent cipher text is G and Q, you go down, that's it. Okay, if they fall in the same row and if they fall in the same column, you just have to consider the immediate next right side alphabet or down side alphabet if it is a column. Otherwise, that means if suppose they fall in a different row and different column, okay, if the two alphabets which we need to replace as a ciphertext, if they fall in the different rows and different columns, in that case, okay, just for example, say H and S, right? Just look at this. I have a H here, I have a H here, okay, and S here, right? Isn't it? So what we have to do? H and S has to be replaced by forming a rectangle, okay? That is, say, let me say here, just one second, I'll use a pen. Okay, H and S, I have taken an example. So H and S, that means they actually form a rectangle or maybe a whatever square or whatever you take depending on your alphabets. Okay, so in a H, in this particular row, the coinciding one is B. For S, in the reverse direction, it is P, right? So you have to replace that by B and P. Okay, let me erase this. Just one second. Yeah. Suppose you have E and A. That's the example what taken there. E and A. So that means one second. Okay. E and A. What we have? Yeah. E and A. So E comes here and A comes here, right? It forms a rectangle. This is the common letter here. A. and in the same row I have a M, right? So that means first I have to replace E by this particular either I or J, it can be anything, your choice, and A by corresponding whatever you have above that E, okay, that is M, no, here in the same row. So you have to replace by either IM or JM. Hope you understood this. So this is the method actually used in the Playfair cipher to get the encrypted version of the plain text. Okay, now suppose I have an example, my own name again. My name is Arun Upadhyaya, so it falls like ARUN UPADHYAYA. First, we have to convert this into the diagraphs or diagrams. Okay, so AR falls in, there is no repetition over here, so I don't have to worry about my first step. Okay, UN, no problem, UP, AD, HY, AY, and I left it only one single A at the end. Okay, so we have to use a filler because I have to convert, anyway I have to represent that as a pair of two letters, that is digraphs. So I include X, a filler letter. Okay, so I converted that, the last single alphabet also as a digraph. Okay, so for AR, what is the answer? For AR, see A and R, it is R and M. That's what it is written over here. UN, so where is U and N here? Okay, U, okay, this one is U and N falls here, right? Corresponding coinciding one is W, okay, and above U is M, right? So replaced by WM, okay. Consider HY, where is H? Okay, so H and Y means Y and B, that's it. Immediate next alphabets, right side, Y and B. Okay, say A and X, where it falls A column, same column, A and X here. Okay, so A should be replaced by immediate down one, B, X has to be wrapped back here, that is A, so B and A. Okay, so my plain text is Arun Upadhyaya, my name, but it is converted to ciphertext, which is again not in the meaningful form, right? RM, WM, BL, RB, YB, and NB, and the last one is BA. So this is the method actually used for encrypting by using Playfair Cipher. Okay, now what way I can say that the security of this one is improved here? Okay, because now you have total possible diagrams of 676, pair of two letters. You can have 676 diagrams or diagrams. Okay, so you have to have that 676 entry frequency table to analyze versus only 26 alphabets what we had earlier in the monoalphabetic cipher. I'm telling you. Okay, we have to guess only 26 alphabets over there, but here it is 676 diagrams. Okay, but it was used earlier in the World War II, World War I basically by United States and the British military in that particular war. But later it was broken, and because again it actually resembles the structure of the plain text, so this Playfair cipher is also broken during that time. Okay. Now I'll take one more example to make you understand how to encrypt as well as decrypt by using this particular method. Okay, what is my keyword is? My keyword is Playfair example. Okay, and in that particular keyword, some of the alphabets are repeated, so I omitted it. Say A is repeated over here, right? And some other alphabets like say L is repeated, right? So only one time you have to enter it. Okay, so you start with the Playfair. Okay, P L A Y, F is done. A is already entered over there, so I go with I, then R. Okay. In the word example, E, X, and M. Only those three are E, X, and M are considered. P, L, E is actually repeated over there. Right. So I filled with this screen. And whatever remaining alphabets I have, I can be considered with the J also. Whenever you write a I, it actually comes with a J. Okay, so remaining alphabets like B, C, D, G, H, all those things are accordingly filled up to Z. My grid is ready and my plain text is also ready to encrypt. Okay, hide the gold in the tree stump. Okay, what I will do first, I will divide this into group of two alphabets, that is say, what do you say, digraphs or diagrams. So when I write it here, the initial diagrams what we get is this. Okay. Now, once I have those diagraphs, I have to check whether there is a repetition. So there is a repetition over here, right? So I have a repetition of double E. You cannot encrypt double E together because it actually gives the structure to the attacker. Double E is replaced by always same alphabet, right? Say E is replaced by what here? It is X, X. That means attacker will come to know that it is the same alphabet. Some information actually are giving for the attackers. So that should be avoided. So what we have to do? Include a additional alphabet, that is X. So with this particular, one more thing is the initial step, we have only single alphabet. But if I include one extra X in between those E's, then I'll get this. Okay. So E is replaced by double E is replaced by what? E and X, E and X. Then E and S forms one diagraph. T and U forms one diagraph. Then M and P forms another diagraphs. Okay, now I am ready with my plain text with additional alphabet X. Now just have to encrypt it. Okay, HI. So first is HI. So what is HI? How to be replaced? H and I. So H here and I here, right? It actually falls in the two different rows. Nah? The same row, that means becomes come with a B. I means it is M. So we have to replace by what? BM. Okay, the encrypted diagraph is BM for this. Now, if I consider randomly, say some TR over there, okay, TR, okay, where is T? T is here and R is here. The corresponding, it actually falls again in the same different rows. T means U, right? R means I, because this I comes above the T, right? Same column, nah? So you have to replace that by what? U and I. So I replace that by U and I. Say M and P. Where is M and P? Okay, so we have M and P here. M will be replaced by I again, right? P is replaced by F. So IF. Okay. Anything which comes in the same row, somewhere you can check it. NT, no. OL, I don't think again, right? No. So EG, they fall in the same column, same row? No. Just have to check it. Okay. Same row, same column is immediate right side or downward. Okay. Now I'm ready with my the ciphertext encrypted diagraphs. Okay. This is the transmitted. You can say same thing. BM, OD, ZB, XD, and all written there, right? This is the transmitted sequence. Okay. Now, how to decrypt it? So here I'll explain how to decrypt it. Same technique we have to use, whatever we used the previous case, encryption. But instead of shifting right, we have to shift in the left direction. Okay. If suppose they fall in the same row, shift in the left direction, opposite of the previous one. Or suppose if two alphabets falls in the same column, then you have to move upward, not downward. Okay. If they fall in the different rows or different columns, in that case, same method. Now say BM. I will start with the BM. Before that, let me erase this. Just 1 second. Yes. Okay. So I'll start with the BM first. Okay. So where is BM? Say B. This is B. This is M, right? They fall in the two different rows. That means corresponding, coinciding H for M. It is I. So I replace B and M by HI. So that is my first diagraph in the plain text. I'm converting a ciphertext into a plain text, right? So the next one is OD. Okay. So I have a O here and a D here, right? Same column. So we have to move in the up direction. So OD has to be replaced by what? D and E. So I got DE back. Okay. Say MO. I'll go with the MO. Where is M? M is here and O is here, right? So M and O. Corresponding letters like E. For O it is S. Okay. So MO has to be replaced by E and S. Right. So in this way, when you decrypt it, what I'll get this as the plain text, a decrypted version, I can say. Okay. Now in this case, just read it. We have a hide the gold in the PR we have. Okay, well, convert it. I have extra X, right? I got back this, not this, nah. So what we're supposed to do is, whatever that extra X you have in this decrypted version, we have to replace that. We have to remove that. Okay. So after removing that one single alphabet, that is this particular X. Okay. If I rewrite this, I'll get back this particular message or this particular message. That is the plain text after removing the X is nothing but hide the gold in the tree stump. Okay, so this is how we can decrypt it. Hope you understood the Playfair example, but still I said Playfair is also broken by somebody, and we have to actually increase the security, because this also gives certain information about the plain text to the attacker, so this is also broken. Okay.